Good afternoon, ladies and gentlemen. Welcome to POE's channel. It's Zoe from POE. Today, I want to share you something about the Nitrogen Reflow Oven. Let's start it. First, what is the Nitrogen Reflow Oven? Nitrogen Reflow Oven is a specialized equipment used for PCBA, a reflow soldering process. Its core function is to continuously inject high-purity nitrogen into the chamber, creating a low oxygen or oxygen-free atmosphere. It's primarily employed for soldering precision components in SMT applications, especially including lead-free soldering, HDI boards, BGAs, and other sensitive devices. 2. POE's Nitrogen Reflow Oven. Notably, POE's Nitrogen Reflow Oven features 12 independently controlled temperature rooms. As the PCBA sequentially passes through these rooms set at different temperatures, it undergoes a predefined thermal profile consisting of preheating, soaking, peaking reflow, and cooling stages. Crucially, this reflow temperature profile must be strictly matched to the temperature of the solder paste used, as well as the heat tolerance of the component under the PCBA, which enables accurate temperature control throughout the process. 3. How the 12 temperature rooms work. The 12 temperature rooms are functionally grouped into 4 stages: the preheating room, the soaking room, the peaking reflow room, and the cooling room. At first, the rooms 1 to 3, preheating room, gradually and uniformly heats the PCBA from ambient temperature to the target preheat temperature, typically less than 156 degrees. It allows the solvent to begin evaporating gradually and can prevent the thermal shock, which can damage components on the PCB caused by rapid temperature rise. Then, rooms 4 to 7, soaking room, raise and stabilize the temperature within the range required for flash activation, typically 156 degrees to 186 degrees, or 186 degrees to 217 degrees, mainly depending on the solder paste, which ensure thorough flux activation and promote temperature uniformity across the PCBA. This minimizes thermal gradient between components with different thermal masses and locations. It effectively preventing the defects like time storming and components shifting. What's more, rooms 8 to 10 peaking reflow zone. This is the core room where soldering occurs. Rapidly increased to the peak temperature, typically 235 degrees to 255 degrees for lead-free solder pastes. The solder alloy fully melts, becomes liquid, and breaks the pipes and components lead or terminations under the action of the flux, forming reliable metallurgical bonds. Finally, the cooling stage. Rooms 11 to rooms 5. Excessive cooling rate can induce thermal stresses issues, while insufficient rate can lead to coarse grain structures or excessively thick intermetallic compound layers. POE typically uses liquid cooling augmented with air cooling, which enable better management of the cooling gradient and cool the PCBA rapidly and comfortably. 4. Advantages of Nitrogen Reflow Oven. Study reduced oxidation. Nitrogen, being a chemically inert gas, creates a low oxygen environment, protect components, PCBs, and solder paste from oxidation at high temperatures. This results in smoother solder joints and significantly improved welding characteristics. For instance, in double-sided reflow soldering, utilizing nitrogen during the first side soldering effectively reduces the risk of oxidation for the second side OSP coating, typically increase double-sided assembly yield by 50% to 20%. In short, POE Nitrogen Reflow Oven can meet higher soldering requirements and advanced products. It also complies with gross leak-free regulations, reducing electronic waste caused by poor soldering, and achieves a balance between high quality and environmental friendly. So much for it. Thank you for your time. Bye.